Hey, hello everybody. We're gonna get started with our webinar here in a second. I'm gonna let people trickle in here for a couple minutes. We had quite a few registers this time, so we will give everybody a minute to come in. So I hope everybody's doing well today and really appreciate everybody joining the webinar. And yeah, so our first of the year. And like I said, I'm just gonna wait a couple minutes before I get started, just so we're not repeating ourselves, but appreciate everybody joining. And if at any point you have any questions or any comments or would like me to go over anything, feel free to raise your hand, ask questions in the chat. We have a couple people here that are monitoring the chat for us as well. So I will get started at 11:02. And hopefully you can see the screen I'm sharing. And I'm sure we have some people from all over. I'm currently right now on the west coast of Canada. It's 11 a.m. over here, so thanks for everybody who's joining from some different areas of the world, some different time zones. Okay, well, we will start with this. We'll see if anybody else trickles in as we keep going through the webinar here. But yeah, so one more time, I'll thank everybody here for joining and we'll get started. So welcome to our first Linac Simulators in Action, a Linac monthly webinar. Thank you for joining us. So this is going to be, I'll just let everybody know, this webinar is being recorded and it's going to be available afterwards to all registers. And like I mentioned before, just raise your hand or put any questions in the chat throughout the webinar, and I'll make sure to get to them when I can. Or, I think I've enabled the ability for you to turn your cameras and microphones on. So if you even just want to yell at me, go right ahead and we can start a discussion about anything that you're seeing. Okay, so this new webinar series is going to be held every month and is here for anyone to join and see SIMAC, our Linac simulator in action. I want to show how our real customers are using our simulators and platforms in their education and training workflows. So every webinar, I'm going to go through a different topic and I'm going to show all the resources that would be available to teach this topic on the platform and how you can use SIMAC, basically like a real linear accelerator to demonstrate that topic. So I do want to show, some physics in the topic. I want to show that, we do have some real results in our simulator, but I also really want to focus on the platform features and how they can be used for tons of other stuff, not just the topic we're going to be covering today. And as a quick reminder, don't forget our free users get 5 simulation runs a day. So log in or sign up and you can even follow along with the demo today. And so, as I'm sure you guys are aware, our topic today is dosimetric principles, quantities, and units. And so today we're gonna explore the platform. We're gonna explore SIMAC, and I want to show it how we can use SIMAC to teach 3 things, and that's what the beam is made of, or our fluence, what the patient receives or absorbed dose, and then how we can then kind of link in some understanding of KERMA as well. So I'm going to start right at the beginning for everybody. So, if I'm teaching myself or if I'm an instructor teaching students, what we'll do is we'll navigate to the Linac platform, as we will all have access to the platform, and we'll all have our own login. We'll be able to access the stuff that is available in our course. And so I get to my platform and now, I want to explore. What I'm looking to explore is some dosimetric principles. And so I want to learn something and I don't know where to go. So the first place I'm going to go, I'm going to touch my my username drop down at the top right corner here. And I'm going to go to student resources, because this is where I can find resources that are going to help me navigate the platform when I'm looking to learn something that I don't really know where that's going to be. So we land here, great. We're in our manuals and guides. We're kind of in the right spot. We can look at the platform guide and the SIMAC guide, but I want to go over to our physics subscription and I just want to look at our lesson guide. And so our lesson guide is really going to be the first place to look if you want to look at a topic or learn something and you're not really sure where to start. So we wanted to look at dosimetric quantities and principles, right? So now we're looking at, basic accelerator theory for medical physics students. Okay, great. Maybe we look at photon beam one and we can look at our target spectrums and our beam quality specification. That maybe seems like a great place to start and get some learning. And then maybe I could go on to photon beams two. And so then it's telling me some topics to read. And then it's also now, this one's also giving me a lab I can do. And then maybe if I go down to our quality assurance, it might be getting a bit out of our topic that we're looking for, but there might be some procedures that they also suggest that I do to learn this topic. And so I just want to show you guys that this is there and available to everybody, and then where you would find that kind of on the platform as well. So, if I was looking at photon beams, I wanted to look at this topic, I would go back to my platform. I would go to our course space. That's where we find all of our course material. And in our textbooks, I would go to our physics textbook or our Linac operation theory. And look at that. There's our photon beam chapter right there. Great. So that's where I can kind of start. I can kind of go through these topics, get some theory behind me, and then I can maybe do my photon beam quiz at the end, make sure I'm really understanding this content. And then maybe I can jump back to our lesson guide and look, okay, maybe let's go do lab 6. So then I would go back to our course space, and then we have these great set of CIMAC labs, which so now we learned the theory and did some testing. Maybe let's get a little bit of an intro without kind of jumping on our full simulators. So they said lab 6. So maybe flattening filters isn't exactly what we're looking for. Maybe we want something more like, relative output factors or something like that. And what this does is going to take me through a little lab, ask me some questions about setting the field size and the depth dose, and then looking at the outputs that we're getting, and then answering some questions, making sure I'm really understanding the topic that we're trying to learn here. So now I've done that, I've done my lab, and then maybe I want to go, so then these procedures, the next step is then to do a real exercise on the real simulator. And I'll just show you guys, so that again are up in our student resources. And then we have these procedures as well, this list of procedures that then you can also, learn the topics that you're looking for kind of on your own. Okay, so that's great. So we did the studying. I've assigned my students that kind of coursework to do without me, and now we're all in a classroom, and now I want to go on the full simulator, and I want to kind of investigate these topics. We want to get some hands-on. We want to look at some plots. We want to look at some numbers and really try to understand these with a more interactive way. So we're gonna go to our CIMAC simulator. And so how we get there is, we click our CIMAC drop down here. Just before I jump over, I'm just going to jump back to our webinar, make sure we're looking okay with any questions or anything. I think we're doing okay. So now back to our demo. We're going to go to our simulator. And so our simulator is found in the CIMAC drop down here. And so what you can see is we kind of have a couple options. We're going to be in CIMAC 2 because that's really our bread and butter. It has the most features, but we do still have our first version of CIMAC 1, which is a lot less features, but maybe a little bit more simple and quick simulations. And then we do have a TG51 simulator that'll take you through a real TG51 test, and I'll do another webinar on that in another month, and we can look at that one at another time. But for now, I'm going to go to CIMAC 2. So the first thing I can choose is our manufacturer, or our Varian Klystron standing wave Linac, or our magnetron traveling wave Electa Linac. And just for simplicity, I'm going to choose the Klystron. I'm going to choose our Varian model today. And so now basically we're on the simulator, we're on CIMAC, and now we have a completely configurable Linac to demonstrate the topics that we're looking at. And what I mean by, kind of your own personal Linac is, so what we do is we kind of start with a default energy, and then we can change the parameters of our Linac, and then we're looking at the outputs. And our outputs are our dose rate. We have our flatness plots here, or our symmetry plots. And then we also have some plots for our PDDs and our energy fluence. And so these are some great outputs that we can definitely look at. So then we could go into our modulator, our gun, our waveguide or our treatment head set up, and we could change those parameters, rerun the beam, and then see how that affected our outputs. That's the whole idea here behind the simulator. That's what you could do with it. And so now I want to show you guys some real things we could look at. And so what we wanted to look at was our particle fluence and our energy fluence, right? So what we want to do is we want to show what the beam is made up here. And what we want to do is we can run some different beams. We can, do some predictions of what would have changed with the particle fluence and then see if our resulting energy fluence spectrum makes sense to what our predictions would have been. So we'll start with a simple one. Let's start with a 6 MV beam. And so I'll show you how to run a 6 MV beam and how we can get our fluence data out. So I'm here, and so you can kind of see we have a low default energy. And if I toggle to another energy, watch the bending magnet current here, it's going to change. So those are the default values associated with that energy. And so if you just toggle back and forth between the energies, you can kind of reset your defaults. So I'm going to run just a default 6 MV. So we go down to here, we run simulator, and then we can obviously see, it's grayed out. We got our little toggle running. We know we're running a simulator, great, or we're running a simulation, I should say. And now we can come back up and really we're just kind of waiting to see our outputs change. And on this screen, we're looking at the dose rate. So when this is finished running, we should kind of see our dose rate change for us. Yeah, so it jumped up on us. I kind of forget what I was running before. That makes sense for 6 MV. And then the next thing I'm going to show you guys that I want to do is we're just going to save this state. So I'm going to call it the 6 MV Feb 19th. So this is a great part of the simulator as well, that you can save any state and then we can call it back later. And so we just save that state like that. And then right there, we see our 6 MV Feb 19th. And so then now anytime in the future, we can call back that state and rerun it and investigate it again. So that's great. Okay, so we ran our 6 MV beam. And so now what we can do is we can look at the photon beam tab. And we can look at our energy fluence. And so this is the plot you can see right here of our energy fluence. And then we can actually export this data to CSV, and we can investigate the data a little closer. So I'll open this up and I will download it. Let's see here, we'll open it up. And I want to just make sure, I'm going to stop sharing and I'm just going to share again, just to make sure I'm sharing the right stuff here. So I'll just share the screen. Hopefully this. Okay, so then this is the data that we grabbed out of our CSV export. So we can see we're looking at the energy of the photons and the energy fluence. And so the first thing we can kind of investigate here is we can, oops, sorry, clicking too many things. First thing we can kind of investigate here is obviously the units. So we can kind of see that our fluence data, it's a ratio data chart here that we're looking at, what ratio of energy photon is getting let through and is contributing to the beam, right? And so the first thing we can kind of look at here is, we have our dose, which is in centigrade per minute, and we have our energy, which is MeV, and then we have our energy fluence, which is, a rate of change or a 1 over your energy and your cheradians and your number of electrons. So it's that rate change, right? And so we can really investigate the different units here and understand why they're different. And then another thing we can look at right off the bat at this chart is we can really investigate which energy photons are contributing most to our beams, obviously, right? So it's a ratio. So we're looking at, the 0.863, that's the most that photon is making up our energy fluence or our beam the most. And then we can really explain to students that, the energy fluence is not the dose, and it's going to be a combination of, a lower energy photon, because that, 0.5 MeV to around 2 MeV is kind of the most efficient photon to create the secondary pair for our dose. And so that's kind of the first thing we can look at when we're looking at our fluence chart here. And then the next thing that we wanted to investigate is, so let's run a couple more beams, and then let's compare these fluence, our energy fluence charts, and then we can kind of predict whether they're going to shift, which way they're going to shift based on, the change that we make to our particle fluence. So I'll just kind of, let me just kind of get organized again here and get this back. So what we're going to do is we will, so in this case, right, particle fluence in this case is going to be the photons crossing an area. So to see the relation, we can either increase or decrease that particle fluence and try to predict the resulting proportional energy fluence. And so to change the number of photons, I can do, many things. And for this example, what we're going to do is we're going to run a higher energy, and then we're going to change our target material. And then we're going to run those, and we're going to look at the energy spectrums and see how they change. So let's run them and compare the results. And so we're going to run a higher energy. So that's simple. We're just going to come over to our default energy. We're going to click the 10 MV. We're going to run it. And then this one I'm going to save as well, just so we can look at it in the future. So again, we have our simulator running. It takes a couple of seconds. And then we'll see kind of the output change. I mean, we're going different energies, so we should expect a higher dose rate, right? So these are all things that we can always look at every run, right? We can always kind of verify the changes with the results in to what we expect to see. So now I've saved this state. So there we go, 10 MV Feb 19. So we can call it back if we want it in the future. So that's great. And then I would go in and I would collect this CSV again, right, for our new Fluence. So here's our new chart. And now I'm going to go back to the 6MV. And I'm going to also do our target material. And so we do our tungsten. I'll change our target material 1 from tungsten. We'll change it maybe to a lower Z material. And we'll go with aluminum. And then, the nice thing also is you can run this simulation from any tab. So now we've jumped in the treatment head. We're changing things in the treatment head, and we can still run the simulation right from here. And we can still save states right from here as well. So you can see the save and load state is here again. And so this one now is a 6MV aluminum, Feb 19th. And so we could wait for that to run. We'll save the state, and again, that'll be there for us in the future. So we save that, and then you can see that 6MV AL Feb 19th. And then we would go to our photon beam again. We can see we got a new Fluence graph, and we could export that data again. So I've taken I've plotted them all on the same graph for us just to look at, so we don't have to do that in front of you guys. So let me find that. Just a sec. Share my screen. That was the chart we saw pop up earlier. And so now, so I've taken our data and I've plotted it on the same plot, and we can kind of, easily see here that our dark blue is our 6MV, our orange is our 10MV, and our blue is our 6MV aluminum. And so we can kind of see, what we would expect with that 10 MV, we're going to higher energy, so you're going to get higher Bremsstrahlung photons, which means our energies should shift or get wider. We should have, some higher energy photons contributing to the dose, and that's what we're seeing here. Where on the opposite side, when we changed our target material to aluminum, we're actually getting lower energy photons because we're raising the attenuation, and then so we're going to see that peak shift to the left. And we're going to see that we're going to get, some lower energy photons contributing to that makeup. And that's exactly what we wanted to investigate here. And then we can also see with all of the beams that, that one or the most energy photon making up the beams are within that, 0.5 to 2 MeV range, which are the what we would predict from, the most efficient photons. And so that's just a quick little example of how we can kind of look at these energy fluence. And then, I mean, there's a million other things you could change. You could go flattening filter free. You could change more materials. You go higher energy. You could change a ton of stuff. You could change your beam current. You could change lots of stuff and then investigate the fluence charts of all of them. So that's great. And so that's kind of the fluence. And so then the next step then would be to kind of investigate our absorbed dose. And so let me just get back to sharing our simulator here. And so now if we were to talk about that fluence, our fluence would get combined with our scatter model in a dose convolution to actually get our dose. And so then we can investigate our dose right here in our photon beam tab. Or I also want to show you that we can look at it together in our water tank. And that's why I saved a couple states earlier. So I'm going to go over to our water tank and I'm going to grab our 6 MV Feb 9th. So I can call it the 6 MV, oops, the Feb 19th, and we're going to do a depth dose, and we're going to run the experiment here in our water tank. And that's just going to give me my PDD, and then I'll run it for my other one, and it'll allow me to look at the PDDs on the same chart, and we can investigate things like, electron depth and your D max for your different energies. So we'll let this run for a few seconds. Great, it ran. And now see, we're selecting the beam, and because I saved it, there's our 10 MV from Feb 19th. So I'll just name it 10 MV from Feb 19th. We'll run this experiment, and then we'll go over to our compare tab, and we'll be able to plot them on the same graph and investigate a few things. So yeah, this run experiment, again, takes a couple seconds, but you can see it's running with our toggle down here, and then this one gets that experiment run green bar show up. So we come over here, so we got our 6 MV and our 10 MV, and that's exactly what we would kind of predict our graphs to look like. And what you can kind of see here is that the Dmax has moved deeper for our higher energy. And you can also see that there's a longer electron range, and you can kind of see that in the build-up period of our 10 MV as well. So there's some things that you can investigate with the dose, and then of course you get this kind of chart afterwards of looking at, it tells you what field size you're running, looks at your Dmax, and then your dose at 10, 20, and then it actually gives you your D10 over D20. And so you could take these, and then in our photon beam again, you can export that data to CSV. You could do things like calculating ROF, lots of other great things that you could do with that actual data, or kind of assign some students or show them some phenomena going on there. So we're running out of time a little bit. I don't want to go over. I want to make sure you guys have some time to ask some questions if you have any, and then we have some questions I want to go over. The last little bit of the demo I just wanted to show you was just kind of to show that we can also do cool things like just give some students some understanding of KERMA, which is a harder dosimetric quantity to really talk about and show. Some people say that it's kind of easy to calculate, hard to measure. So, but if we looked at like a simplified KERMA formula like this, where it's really the sum of our fluence times an absorption coefficient times a change in energy. If we go back to our data that we're looking at, I think I have to stop sharing and share again for you guys. If we go back to our data, and looking at our data, we can really see that there's an easy relation with that KERMA formula and the data we're looking at here. Obviously, it's a relative. We have the relative data for the fluence here, so you would get a relative KERMA value as well. But you can see that we have a fluence value, and then we could look up this chart. These are just coefficients, and then our change in energy would just be the delta between the energies of each bin. And then so we could then do the multiplication, do a big sum, and we could easily get a simplified KERMA value out, and just kind of show that KERMA is the combination of all those photons making up the fluence and the beam, right, and our dose. So but that's I won't do the calculation or anything. I just kind of wanted to show that there's some other relationships that we can also teach just with the values and the graphs that are coming out of our simulator. And so that's basically what I wanted to show you guys. There's a couple different examples of how we can look at some dosimetric principles and units. And of course, this is just a small slice of all the features that are available there. And like I said before, you could go ahead and you could do flattening filter free, change all your different materials, lots of different energies. And then of course, that's all mimicked again on the Electa machine as well. So there's lots and lots that we can do. And so that's going to be kind of the end of our demonstration for today. So I'm going to leave it open for some questions. If anybody has some questions, please just put them in the chat, come on the mic. I'm happy to discuss. And then, we'll be back next month, and I'd love to hear, some topics that people want to hear and want to see that we can do. So these are some questions and requests we got on the registration form. So people are asking for quality control and radiotherapy, SRS and SBRT, unit monitoring, FFS specifications and commissioning, and QA and dosimetry. So I'll make sure to take this into consideration when we're doing our next one and see what we can do to cover some of these topics. And then we had a question of how do I get this software? And so online, this is completely free. You can use it 5 times a day for free to really get a feel for it. And then all of the stuff that I showed you today is available in our physics teaching package. And so that can be purchased through the website. And please just reach out to us. I guess I'm not sharing. I was just showing you guys these questions, but please reach out. I'll put my email in the chat here, and it'll be up on our website as well. That if you'd like a further demo or a trial of our physics package, please reach out to learning at linacs.ca, and we can totally help you out. And we can get you started on a trial. We can get you understanding what all the features of our platform and of our package. So that's, I guess, me talking a lot. I don't think we have anything in the chat, but I really appreciate everybody that showed up today. Thank you so much for joining us today. Hopefully it was useful. Hopefully you could see some of the things our platform can do and see if it's the right fit for you and your team. And like I said, please just reach out if you'd like to learn more, if you'd like to investigate more, see more. Yeah, thanks guys. Thanks to here. Thanks AJ. Have a great day. And then, of course, I'm going to get this recording out. I'm going to send it all right to you guys in email. So you'll have an easy way to get in touch with us. And then it'll get posted to YouTube and all that good stuff. So no problem, guys. Thank you so much for joining us. And hopefully we see you at the next one. We're going to do the monthly, and we want all of our users there. I want to hear how you guys are using the simulator. We want to see it, and everybody wants to see that. And I'm just going to hang out for the last couple minutes just in case anybody has some things. See you next month, Sahir. That's great to hear. And invite your friends. Tell everybody about it. Tell everybody about our Linac simulators, and that we can get you your own personal Linac for your desk. If you want to investigate beams, if you want to learn more, teach anybody, that's what we're here for. That's what our simulator can do. Amazing. Thank you, Zahir. Hey. Okay, well, that seems like what we have for today. So I'll just end the event and I'll kick everybody out. So everybody have a great day. And yeah, we will talk soon. Yeah. Thanks, Zahir.